Algebra 2, Trigonometric Function, Characteristics and Equations. Trigonometric in high school is a separate one semester course, and we're going to cover that one semester into compressed one video. So it's going really fast. The video you can look at many times and practice each section of video, and you can master the trigonometric. Usually, I think most of high school in the United States, trigonometric is separated from Algebra 2, and it is an option to take for student. The student aiming at engineering or science must take it. So it's not qualified as the entire year subject, but the 1 quarter or 1 semester, because it's a lot of content inside. So mostly you have to practice. Time for practicing it's require a lot of time, and also a lot of SAT program, they like to give out the questions using trigonometric. So let's see. So what is a trigonometric function? Okay, in the geometry is kind of strange. You learn geometry at the elementary level and the middle school somewhat, and geometry for high school. And geometry for high school is complete theory, Euclid geometry. But during this period, you learn geometry based on the obvious, the human perception. And one of them is triangle shape. And you have a triangle, and elementary or middle school, you learn that the right angle triangle is going to define the value ratio, hypotenuse lengths, and AB, and A over L is defined as cosine theta, right? And B over L is sine theta. Okay, so that's the extent of trigonometry you learned so far. But in high school here, trigonometry is, you learn this as a function. So the function, of course, y equal fx, and the x is angle, like 90 degree, 45 degree. Okay, now the first things you do is to redefine the unit of x. The angle you can define by degree, right? And degree is when you go round once, total 360 degree. That's just the rule. Okay, it's not like a x, y. The theta is degree. Now we redefine this using radian. So what is radian? Radian is 360 degree is defined as 2 pi radian. So it's like 2.54 centimeter is defined as 1 inch, right? The same thing. 360 degree is defined as 2 pi radian. Why 2 pi? Because the length, the circumference total is 2 pi, and if it's a unit circle, r is 1, right? And that's the 360 degree. So the unit of radian is 1 radian is actually 1 radian is defined as length of radius r. So when you take any circle with the radius r, the lengths are gonna give 1 radian. How many radian does it give for the entire circle? Is 2 pi, right? So 2 pi r is a circumference. Okay, so that's the way radian is defined. So using radian, y equal fx, x is given by radian. So that's the function of y equals sine x, cosine x, and tangent x. So you have to know pi over 3 is 60 degrees, same. 3 pi over 2 is 270. 1.2 pi is 316. 7 pi over 2 is 270. Okay, you can stop the video and go over this. Just make sure it's correct. It's like centimeter, inches, or the foreign currency like Japanese yen to US dollar, right? So this conversion, you should be able to do it. 2 pi is equivalent to 360. Okay, convert the degree to radian. This is the other way around. So when you learn trigonometry by this, the theta was degree, right? Because you measure the angle by degree. Now in the math, degree can be used, but we rather use radian. Okay, so that's the first step. And usually when you say trigonometric function, the variable is defined by radian unit. Okay, so if you take a unit circle like this, right? And this function is kind of strange because you have a radian. Theta is y coordinate on the xy coordinate. Y over r. Cos is x over r. That is corresponding to what you learn in triangle, right? Okay, tangent is y over x, right? So it's corresponding. But here the difference is this variable here can go through one circle, and second circle, and the third circle. It can go forever, right? So it's go other way, it go negative too. So the major difference between this and trigonometric function is the range of variable. This based on the triangle, so range of variable is limited to x is 0 to infinity, right? Y is 0 to infinity, right? Okay, but the angle is 0 to 360. This angle limitation is removed in this trigonometric function. The theta can be negative infinity. That means you go backward, circle this around many times, or you go this way forward, circle around many times as you want. The function is still defined. So what's happened is the function is going to repeat it. 2 pi is one circle. After 2 pi, function is repeated, right? So every 2 pi, and actually tangent is going to be repeated every pi. Okay, so what's happened is, and also cosine is even function. If you carefully look at the ratio of this and the ratio of this is negative and this negative. This length is not negative, so even the angle is this amount, it's going to be even. Sine is odd function, and the tangent is also odd function. Okay, so we went through the type of function in the several video back there. You should go back and look at if you're not sure what even odd function is. So those are the characteristics of trigonometric function. And if you put the graph, you can tell cosine start with 1 and become negative, come back to 1 at 2 pi. And it's a repeat. So you know why repeat, right? Because this move one circle, then remaining is same thing repeated. So the function look like repeated waveform. Sine start with 0, right? And sine start with 0 and 2 pi, it's repeat. The tangent is a little different. It's repeat between minus half pi to half pi. This range and tangent to go infinity. Here's a singularity. The every pi, the range of pi, singularity show up, because when triangle is like that, its height become infinitely large, tangent become infinite, right? So 90 degree, right? 90 degree is 1 over pi. So every pi over 2 on the both sides of the x-intercept is a singularity. Singularity here, singularity here. So tangent repeat every pi, and cosine repeat every 2 pi. Sine repeat, sine function repeat every 2 pi. And you notice here immediately, sine function and the cosine function is the same, exactly the same. It's just shifted. Okay, so how much you have to shift it? So cosine, if you shift by pi over 2, it becomes sine, exactly same sine function. Okay, so sine function shifted sine function, cosine function is same as a sine. The same way, if you shift to sine, okay, this one is like, if you shift it, it's become, okay, so it's different, opposite of sine. This is sine, this is negative sine. So if you shift the sine, it become cosine. Cosine, if you shift pi, okay, negative, and if you shift the sine, it's become negative. Okay, so this is a major characteristic of the trigonometric function. And tangent, if you shift the pi, it's identical. Every pi, the same tangent function shows up. Either add pi or subtract pi, you shift the pi in either direction, it come back to tangent, same tangent. Okay, and you can tell by this equation, tangent x minus pi equals sine x minus pi, and shifted sine by pi, shift by pi is going to be negative, the cosine same way, so it's come back to the same pi tangent. Okay, so which function is odd and sine? Well, I already explained to you. Cosine is even function, sine is odd function, tangent is odd function. Okay, so we keep going. This video is crash course of the trigonometric function. So if you're not sure, stop the video and review and do some practice so you can follow. Here's some practice question. Expand the double angle trigonometric function. Expand double angle using sine x, cos x, and tangent x. So this 2x can be expanded into this. Okay, this proof, you can do it if you manipulate sine, cosine, tangent function, but I give you very clean way to prove this using Eulers Formula. Okay, so for now you accept this because there will be a general formula for sine a plus b equal, and this formula, if a equals b, then this is going to be sine 2x, right? This is going to be x. So this is a special case of the general formula, and general formula can be proven by Euler's equation. So it's coming up later. So for now you accept this, and using this result you can go opposite way. Okay, use the result above, make the half angle formula, the half angle, right? Okay, so it's basically same thing. The one thing you have to remember is there will be a lot of formula for the sine, cosine, tangent, because they are so closely related. You know, if you shift the sine, become cosine, the cosine shift becomes sine, and tangent is a ratio of sine and the cosine. They are so closely related. You can find out many relationship, and memorizing the formula become major task for student before exam. But after exam, most of students forget about the formula because there are so many formula. It's only important thing is to remember where to go back and find out the formula so you can use it. You always know how to break double angle into the single angle to the double angle, a half angle to the full angle. Okay, so you can always find a formula, but the major formula you have to memorize it for SAT test. Okay, SAT 2 particularly, that you need to know the important trigonometric function, and beside the formula some value you have to memorize. Okay, we know this, right? It's called a periodic function. Trigonometric function is a periodic function. Important thing is cos 0 is 1. Cos start with 1. Like that. And the sine 0 is 0. Sine start with 0. Okay, so this is sine, this is cos. So halfway cos is 0, halfway sine is 1. Pi over 2 is 1/4 of 2 pi, right? So you go 1/4, drop to 0. If you remember this waveform, you can tell cos pi is -1. It's here, right? Sine pi equals 0. This is pi, half cycle. Okay, so if you remember this basic form for cos and sine, you can pretty much tell what kind of value it's going to be at the quarter and half of 2 pi. So you can answer those very quick. Okay, try this out. Use a paper and a pencil, stop the video, and just confirm this. Okay, so there is a interesting formula, and you have to remember this. The area of triangle is square root of s minus a, s minus b, s minus c. What is s? S is a plus b plus c over 2. Now this is called Herons formula. And S, you have a triangle A, B, C, right? You add them all and take a half. This, using this S triangle, this area A is the square root of S, S minus A, S minus B, S minus C. Okay, this is another formula. A square is B square plus C square minus 2bc cos x. And we'll prove these formula later. By using this, you follow this proof. Okay? Then you can prove the Herons formula. And usually SAT 2, those tests, they don't ask you to prove, but they ask a question that you need to use the Herons formula to calculate. Okay, so this part, the basic stuff, you have to remember. But if you doubt it, if you have to go through the proof, it's not that hard to go through the proof. Okay, and once you go through, then formula get into your brain permanently. Not really permanently, but you know, you forget sometimes, but you look back and you feel comfortable because you have proven it once. So I suggest you go through once. Okay, so you can stop video and go through this proof. I told you we're going through 1/4 or 1 semester trigonometric lectures in single video, and there's no way, unless this is just a review for you, you can finish up all the trigonometric lecture in one single video. If it's just reviewing, then I think it's fine. You can just keep going. Okay. Here's a very important formula. It's called Trigonometric Pythagorean Formula. What it is x squared y squared equal r squared, right? That's a Pythagorean formula. And if you divide by r squared, then you get this one. Okay, cos square plus sine square is always 1. And this is important formula. And also, if you divide both sides by cos square, then 1 plus tangent square is cosecant square. And you know cosecant, right? Cosecant x is 1 over cos x. And what is secant? Secant x is 1 over sine x. Okay? So this formula is very critical, and it's show up many times, even in later on when you learn the calculus, it shows up. So this is a must. This is the must that you remember. And there are two formula about sine and cosine. Law of cosine and law of sines. There are two important formula about sine and cosine. Suppose you have a triangle ABC in this way. A, the angle is A on the other side. C, angle is C. B, angle is capital B. Okay, in this arrangement, we can say sine A, the angle A, by length A is the same as sine B over B. This is called law of sines. It's good to remember this too. And law of cosine is this, which we use this to prove the Herons formula. Here you go. Here you go, this one. So using this law of cosine, we have proven Herons formula. So this is the basic formula you have to remember. And this one become very trivial formula when you learn the vector. So the range of x value between 1 and what? Probably it's not the range. Probably cos x or sine x. The range is -1 and 1. Okay. Find the area of triangle that has a length of 10 at the bottom and 35 on the left and 45 on the other end. So you have 10 and 35, 45, right? And find the area. So use the law of sine. You say this is A, B, C is given. So probably this is A, this is B. The A side 35 degree, B side 45 degree, and the 10, this angle is 180 minus 45 minus 35, right? Because all the internal angles, sum of internal angle is 180, right? So since we know this value, we can calculate A and B. And once we know A, B, C, use the Herons formula, we can calculate the area. Okay? So combining Herons formula and trigonometric basic formulas, law of sines and law of cosines, pretty much you can fill out area of triangle, any kind of triangle. Okay, that's a power of algebra 2 now. Practice of trigonometric function, important formula. In a triangle, A is 15, B is 10, and A 45. What is angle B? So this is the A and 45, and B and what is this angle? So using this, the law of sine, we can tell x is 28. And you need a calculator for this. In a right triangle, and the calculator is allowed in SAT too. So you have to practice this, how to use calculator to get the final answer. In a right triangle, one angle is 35 and hypotenuse A equal 10. Find the B. Okay, so you know how to do this. Stop the video, prepare pencil and paper, and practice here. Here's another practice. Practice of trig function important formula. Okay, so in a triangle A equal 10, B equal 13, and the angle between is 45. Find the C. So you have A is 10, B is 13, so it should look a little bit longer, and angle is 45. So this is C, right? And this is C. So use the law of cosine, right? Then you get the C. Now in the obtuse isosceles triangle, one angle is 10, so obtuse isosceles. This is larger than 90 degrees, and this is same. One angle is 10. That means this side is also 10, right? And this one is 180 minus 10 is 160. Obtuse. Okay. So you know how to calculate this. Important thing is to do practice. Okay. Instead of listening how to solve it, you got to try to solve by yourself, and that's the way you polish up your skill in the math. More important things in the lecture is to learn something new, which was done by a great mathematician like Euler. He came up with this, okay, using exponential function and imaginary number. Wow, the power is imaginary number, and to him it's just a number. All the number, complex number, whatever, it's a fair game to him. It's a number. So he discovered that cosine x function is actually exponential function with imaginary number power plus negative over 2. How did he discover? You learn this in calculus. We can prove this. It's not that difficult. Okay? But first guy who discovered, that was difficult. And the second guy and after, it's easy, because what they do is, oh, I see. Right? So sine is only the difference is, you have to know sine x equals ix negative minus ix over 2I. And you can tell this is sine x is odd function and cosine x is even function. So if you put that in, you can easily prove trigonometric addition formula. Sine x plus y can be broken into this. Cosine x plus y can be broken into this. And trigonometric multiplication formula can be proven using this one easily. Okay, so this formula, there are many ways to memorize it, but usually they memorize it only before exam. So I don't think it's really necessary to make an effort memorizing it, but you got to know that you can break this multiplication into this or addition into this. Okay, for example, sine 15 is sine 45 minus 30, and you know sine 45 and the cosine 30. So using this number, you remember, you can figure out sine 15s. Okay, so this is a famous trigonometric addition formula and multiplication formula. Both can be, once you have proven this formula, then you can do this practice, find the value x that satisfy this equation. Okay, now this immediately you have to know cos square plus sine square is 1. So replace cos square with 1 minus sine square x. So sine x y, sine x equal y, and y minus 2 is 0, and the y range is minus 1 to 1, so this is non-zero, right? So answer is y is 0. What y? Sine x is 0. That means 2 pi n, where n is 0 plus minus 1 plus minus 2, so and so. Okay. You can go through this, slowing down the video. Okay. Trig function addition formula practice. Okay, here's a practice. Now look at this practice. Stop the video and paper and pencil, and make sure you understand this red ink answers for those values. Trig function addition formula practice. This is also practice. You got the practice, and root of sine and cosine, find the value of p. Okay, this is a challenge and some word problem. Okay, so now you're getting into the area that you can handle some kind of radio wave. Radio wave is typically sinusoidal, that means sine waves, and they talk about frequency and stuff. So if you have a 5G, it's a microwave, what gigahertz, you can do some calculation. Once you know the waveform is y equals sine wt, but actually usually in engineering they use Greek omega t. I don't know why it's w, maybe typed wrong. And it's interesting to see if you understand these microwave questions, and that's a part of new technology like 5G, especially it talking about 20 gigahertz wave. That's definitely high frequency 5G signal. So I hope you get interested in this to go through. Stop the video and pencil and paper, practice. Try to solve this, try to understand. This is the answer. So look at the answer if you're not sure, and practice. Okay, and trigonometric function, the most important thing is to practice. I'm telling you, I'm giving you the hint. Okay, so I hope you enjoy this listening this video, and I see you in the next video.